take a look at this particular problem where we're given a logarithmic function. F of x is log base 4 of the quantity x plus 2, and we wish to find the domain of this log function, its vertical asymptote, and its x-intercept, and use those pieces of information to go ahead and graph the function. Now, to get the domain of any log function, no matter what the base is, no matter what's inside the log, the way we proceed is the following way. You're going to take the quantity which is inside of the log, and you're going to make sure that it behaves, okay, to get the domain. You're going to set this quantity greater than 0. So you have an inequality that you need to solve for x, and we would get here in this case that x is greater than -2. Use a number line to go ahead and draw what it looks like, and write your final answer in interval notation as -2 in parentheses, comma, infinity. Of course, infinity gets a parenthesis. So this is the domain. Now, to get the vertical asymptote of such a function, remember that the quantity inside the log is the quantity x plus 2. To get a vertical asymptote, since it's an equation you're looking for, you will have a sign equal showing up, and you need to remember that to get the vertical asymptote, you need to go ahead and take over here the quantity x plus 2 and set it equal to 0 over here, and solve for x. And we get that x equal to -2 is the equation of that vertical asymptote. And of course, it's a vertical line when you have just one variable, the variable x, equal to a number. To get the x-intercept of this function, you need to remember that no matter which function you have and you're graphing it, if you want to get an x-intercept, you need to let the other variable y be 0 and solve for x. Now, y is f of x, and if you remember, we decided that the function we're working on is f of x is equal to log base 4 of the quantity x plus 2. So you can write it as y is equal to log base 4 of the quantity x plus 2. So if we let y be 0 for y being the log base 4 of x plus 2, we're going to have log base 4 of x plus 2 being set equal to 0. Now remember, we used to zap the log if we wanted to solve, in this case, a logarithmic equation over here. So when you zap the log is gone, and then that base which you have, which is, in this case, let me get the pen to work, this 4 over here, which is the base, you're going to make that base travel to the other side. So what you have on the left is just x plus 2, the quantity inside the log, and that's equal to 4, the base that traveled to the other side, raised to the exponent 0 over here. So you have x plus 2 is equal to 4 to the 0 is 1, is equal to 1. Then subtract 2 from both sides, and you get x is equal to -1. But remember, over here, we do have an x value that we just found, and it's associated with the y value being 0. So you do get a point, and the point is the x-intercept, and you mention x first before you mention y. So the point is -1, 0. Now let's see how this leads to a graph. So if you take a look at how I graphed, this log function, I drew first over here the vertical asymptote at x is equal to -2. Then I plotted the point -1, 0, and then I went ahead and I drew basically the shape that we have for a log function, and it looks like what I have over here, passing through that intercept